jumping from some baseball references to some Star Wars references, we have a 0.1 kg lightsaber, and if you don't know what a lightsaber is, think of it like a sword that is made out of light. It's incredibly light, no pun intended, but 0.1 kg, incredibly light. It's accelerated from rest at a rate of 2.5 meters per second squared. And I want to know what the kinetic energy is after it's gone a distance of 1.5 meters. So knowing that EK equals 1/2 mv squared, we have the mass, 0.1 kgs, but we don't have the speed. You might be thinking, oh, it's at rest, so v is 0. Well, that would be v initial when it's still in the fighter's hands, but what matters is after it's accelerated for 1.5 meters, so the final velocity. So again, we're going to kind of have to work backwards. We know the end game of this is that EK equals 1/2 mv squared. We need to get V, specifically VF. So this goes back to the Unit 1 kinematics equations. We have a multitude of equations that we can use to get to VF, so it would be really useful this time to define the variables beforehand before we pick an equation. So what we know, m 0.10 kg, not going to have an effect on finding VF, but we will need it for kinetic energy. We know the acceleration is 2.5 meters per second squared. We know the distance it's traveled at 1.50 meters. We know that VI is going to be 0 because it's accelerated from rest. And VF is what we need to find at this point. So the variables that matter now are A, D, VI, and VF. One equation has all of those. That would be VF squared equals VI squared plus 2AD. Substituting in what we know, VF squared equals 0 squared plus 2 times 2.5 times 1.50. Zero squared is going to be 0, and 2 times 2.5 times 1.50 will be 7.5. Square root both sides, and we get that VF is 2.7 meters per second. Knowing that, we can slide over to the kinetic energy calculation. We have what we need now. So EK equals 1/2, M is 0.10, V is 2.7, and that is squared. Can one-stop shop that in the calculator. Going to 2 sig figs, we get that EK is 0.36 joules.